Hello everybody, my name is Joshua Teeters, and today I will be showing off a project I made for my Computer Networking 361 class, Workstation and Server. Now the aim of this project is to have a user try to go to a real, legitimate website, but instead be redirected to my fake website, where I can prompt the user to log in and steal their credentials. Once the credentials are stolen, I will redirect the user to the legitimate website they were trying to go to in the first place, and with any luck they will not be able to tell that anything unusual happened at all. I will be doing this by sending a Trojan to the user's computer that modifies a local DNS cache file. This project is already set up, and there are instructions on how to get to this point in the description below, but I will quickly run over the broad steps I took to set this up. First, I installed VirtualBox and created two VMs, one for the user, computer A, and one for the hacker, computer B. On the screen currently, we have both of them pulled up. On the left is the unsuspecting user's computer, which is sized slightly bigger. And on the right is the hacker's computer, sized slightly smaller. They are sized differently, so you can hopefully tell them apart at a glance. They are also labeled up at the top in the title bar, and you'll be able to tell better once we get some software running on these. On the hacker's VM, I've installed a few tools that will help us out. One of them is MySQL. This will allow us to create a database of the stolen credentials. This is not particularly needed, but it provides a nice standard way to store the information in a way that is extremely usable for future use. The other tool I've installed is Node.js, and this is what will be hosting the fake website I've created. Let's take a look at the website we will be targeting today. If I open up Firefox on the user's machine, I can browse to coolmathgames.com. This is a website that I used to go on when I was younger to play games. You can play some educational games like chess, and the games just run in your browser like this. Now the way that I was able to make a nice looking replica of this is by utilizing the built-in Save Page As feature. So if we go back to the home page, we can right click on a blank space here, and it's Save Page As. That'll save it as a web page complete. Doing this will let you download many of the parts of the website for local offline use. Now, what we're going to be doing is taking these files that are meant for local offline use and hosting them so that others can connect to it, and it will look like the real thing. I must mention that the download is not perfect, and you will need to edit a fair bit of the files if you wish to do this yourself. Again, all the setup instructions to get to this point are located in the description below. With the setup aside, let's go ahead and show off the execution of this attack. On the hacker's VM, I'm going to go ahead and pull up a command prompt and browse to documents. This is where I've stored all of the files for the fake website that I've made. I'm going to set some required environment variables, which I have not hard-coded in to make them easier to change for anyone that wants to. So first we're going to type set debug equals documents. And what this is going to do is just set the debug location to the current folder that I'm in, which is documents. And the next thing that we're going to do is set the port, which is going to be the port that the web server is hosted on. We're going to set it to 80. That's a pretty standard web server port. And lastly, we can type npm start to actually start the web server. And you can see we have confirmation that there's a server listening on port 80. We can go ahead and leave this alone for a little while. Heading back over to the user's VM, I've got open an administrative PowerShell prompt here, which we can use to view the contents of the local DNS cache file. It is located under Windows System32 drivers, etc., and it's called hosts with no file extension. If I open this up in Notepad, it provides a nice description of what the file is used for and an example of how to add custom entries to the bottom of this list here. Now, right now the list is blank. All of these lines are currently commented out using the pound symbols here, and we'd like to edit this. But asking the user to go find this file that's buried deep in Windows files and put in random IP addresses might raise some suspicion. So what we're going to do instead is we're going to edit it using a script. And we're going to present this script to the user as a Trojan. Now, you can add this Trojan into some other legitimate software or name it something that sounds nice or whatever you can do to get the user to run it. You can see we have it right here on our desktop right now, and we can go ahead and run that right from the command prompt here. Trojan.ps1, hit enter. Now that's going to do two things. The first thing it did, let's go ahead and pull back up that file that we were just on. First thing it did is add a new entry to the bottom here. So you can see it added 25.146.212.56 space coolmathgames.com. Now this is actually the IPv4 address of the hacker that we have over on the site here. If you were to go to the command prompt on the hacker and type ipconfig, this is what would show up. Now the rest of this entry says that anytime that there is a request to DNS to resolve the host name coolmathgames.com, what it should do is just immediately return this IP, which is the hacker's IP right here. Now the second thing that the script did is it flushed the DNS cache. And you can see we have some confirmation of that here. Windows IP configuration successfully flushed the DNS resolver cache. And what that's going to do is ensure that there are no other files on the system that are going to be caching the actual legitimate DNS results for coolmathgames.com. So what we can do is we can go on over to Firefox. We can type in coolmathgames.com, and we can hit enter. And on the right side here, you're going to see all of the web requests being fulfilled. And on the left, we can see that we just loaded into coolmathgames.com. It looks legit. We even have some advertisements on the side. But this is my fake website that just got loaded in here. There's a few small ways that you can tell that this is a fake website. The most noticeable way that I did it is I changed the top picture here to be this girl smiling at me. And now this is not the correct picture for Foxbot. It's actually the picture for one of the games that's further down here. Yeah, Pop Tropica right here. But I changed it just so I could see at a glance if this was the real site or the fake one. Now this is obviously not a required step, and if you were doing this for real, you would not want to do that. But honestly, even if you left that in, I'm not sure I would be able to tell that that is not the correct picture for Foxbot. The most important part of this, though, is that up top here, it says we're on coolmathgames.com, which is the actual site. I don't see anything that's wrong with this. It doesn't raise any suspicion. I have no reason to suspect that anything is amiss. Now you can go and actually click on these links, and it will take you to the actual games. You can play them. It just redirects you out from my fake site. But if I was a user on this site, the first thing that I would want to do is log into my account to make sure that I get all my game tracking in and I can save all my games and get achievements and whatnot. And you can log into my fake website the same way that you would the real one. I'm going to scroll over here to where there's a login button. You can hit it. You can see all the web requests being fulfilled on the right side on the hacker's view here. And we're going to browse on over to the form, and it asks to put your login ID or nickname and your password. Now when I click on it, a few things pop up here. One of them is actually a security warning. It says this connection is not secure. Logins entered here could be compromised. And okay, that might make me think twice about entering in my credentials here. But from what I can see, it looks like the correct website. All the links work. The URL is coolmathgames.com/login. That seems about right to me. It even pulls in my saved passwords from the legitimate website. These are actually entered on the legitimate website. So if I click on them, it'll autofill for me. Everything seems right. And you can go ahead and hit login. Now, before we do that, though, I want to go over and pull up the database that's going to be storing these credentials once they're grabbed. So we can go ahead and open my SQL workbench on the hacker's end here, boot into our local instance, and we can ask to show all of the information that's currently stored in the database right now. You can run it. You can see in our result grid down here, we have 3 columns: a username, a password, and a unique identifier ID number. Now we have one entry that's in here already. This is a test one that I used previously. The username is user, password is pass, and the ID is 1. So we're going to go ahead and hit login on the website, but we're going to pull up the console first here so you can see what it's doing. Once I hit login, a little bit of information will be displayed on the console here, and it'll actually log me into my account. So you can see Amazing Dinosaur 807, that is my randomly generated username. This is my profile picture. This is my background. You can see I last played chess for 7 minutes. This is completely the actual website. This now you can see HTTPS. That is one of the giveaways. This is actually the correct website. I can go back. I can browse games. I can play some more chess. I can go beyond my merry way and have no idea what just happened. But if I go back over to in the console here, you can actually see that I got the post information that was sent to the server. So you can see the name and the password fields, Josh Teeters an example, I was actually able to take those from the request that it made. If I go back over to the database and I ask it to, once again, show every entry that's in the table right now, you can see that there's a new entry here. Username Josh Teeters, password example, and an ID number of 21. From a user's point of view, the login went smoothly and there's no reason to be suspicious. Other than a few minor details here and there, the whole process didn't seem anything different than what they normally do when they try to log into this website, except now I was able to take their credentials. That's all that I have for you today. If you want to try it out yourself, be sure to check out the steps in the description. Otherwise, have a nice day, and thanks for watching.